Welcome to Vision Plus and welcome back to this senior form mathematics and complex numbers. We are now doing example 5 under the rectangular form. Example 5 says that we need to write the complex numbers below in the Cartesian form. As you can see, they are in the polar form. Remember, there are three formats of the polar form. One is that r cos of theta plus I sine theta. 2 is r comma theta. 3 is r, and then you put this angle sine theta. So this example 5 is in this format, where r is the modulus and theta is the argument. So to go to example A, which is 5 and the angle is 30 degrees, if we are to compare it to this formula, it implies that r is 5, theta is 30 degrees. So to change it to the Cartesian form, we need to find x and y, and then we substitute for them in the formula for Cartesian form. And we know that x is given by r cosine of theta. This means we shall have 5 cosine of 30 degrees. And then you press the calculator. 5 cosine 30. I'm getting 4.33, 4.3301. And then for y, you know that y is given by r sine theta. This means that we shall have 5 sine of 30 degrees. And this gives us around 2.5. 5 sine of 30, 2.5. 2.5. After getting x and y, you know that the Cartesian form or the rectangular form is given by x plus iy. Substitute for x and y. X is 4.3301 plus y is 2.5. Then you attach I. That is the imaginary part. So that is how we do part A. Going to part B. Part B says that we have 3 and the angle is 120 degrees. This implies that our R, which is the modulus, is 3, and then theta, which is the argument, is 120 degrees. Now let us get x. We know that x is given by r cosine of 30 degrees, cosine of theta generally, not 30. 30 was for this number. This means that we should have 3 cosine of 120 degrees. And then you press the calculator. 3 cosine of 120. Negative 1.5. Negative 1.5. Then you go to y, which is given by r sine theta. This gives us here 3 sine of 120 degrees. Then you press the calculator. 3 sine of 120. I'm getting 2.5981. 5,981. Let me confirm. 3 cosine of 120. Correct. 3 sine of 120 is also correct. After getting x and y, then we know that the Cartesian form is given by z is x plus iy. This implies that our x is negative 1.5 plus y is 2.5981, but you attach I, that is the imaginary part of the complex number. So that is the solution to part B. Let us go finally to part C. Part C says we have 8 and the angle is 90 degrees. That means the modulus R is 8 units and theta argument is 90 degrees. And you get x by saying x is given by r cosine of theta. This means that we have 8 cosine of 90 degrees. Then you press the calculator. 8 cosine of 90. 0. Here we're getting 0. Because cosine of 90 is 0. And then we go to y. Y is given by r sine theta. This means that we shall have 8 sine 90 degrees. This is around 1 times 8. That will be 8. So 8 sine of 90, it is 8. Why? Because the sine of 90 is 1. After getting x and y, then we substitute, because we know that the Cartesian form is given by z as x plus iy. Then we substitute. What is x? X is 0 plus 8i, or I8. The order does not matter. It is a multiplication. Just like AB is the same as BA. It is a product. Then if you add 0 plus 8i, it gives us only 8i. So this complex number here does not have the real part. Why? Because it is at 90 degrees. That means on the imaginary line, on the imaginary axis, all the values of the real part are 0. It's just like saying on the y-intercept, x is always 0. It is the same case here, that on the imaginary axis, the values of the real axis are always 0. So this is the solution to part C. And now that is the overall solution to example 5. We have come to the end of complex numbers. This is the end of complex numbers. This is the end of complex numbers. So if you have questions, please send them to us.